Okay, today we're going to be converting degrees to radian measure and vice versa, radian to degrees. So just a brief review and explanation of the radians. Go ahead and draw a circle as best you can. Draw a circle. Kind of explain where this conversion little formula comes from. And go ahead and draw the circle first. It's easier, then draw your XY axis. Okay, and then go ahead and draw a degree in there, or an angle. Okay. If this is x degrees, that's x degrees. In geometry or math 2, if this is a central angle, this arc is also x degrees. Right? Okay, radian measure, though, is a length in inches. Okay, so radian measure, okay, that's the length of the arc on a unit circle. So it's the length of an arc on the unit circle. Circle. Okay, so radian measures the length of the arc. Okay, in inches, centimeters, something you can measure lengthwise. And unit circle, what was the radius on a unit circle? 1, the radius of 1. Okay, and I think of this as also, since it's the length of the arc, isn't it just part of the circumference? Yeah. It is. So I call this, it's a fraction of the circumference. Okay. So it's just part of the circumference. That's the radian measure on a unit circle. Do you guys remember what the formula for circumference of a circle is? 2 pi r. Okay, so circumference equals 2 times pi times the radius. Okay. Which on a unit circle is kind of easy, isn't it? Okay, it's 2 pi times 1. Okay, but we'll get to that. All right, so it's a fraction of a circle. Well, how many degrees are there all the way around? 360 degrees. Okay, so if I say let's go 90 degrees, isn't that 90 out of the 360? What fraction is that? Quarter. A fourth. 1/4. So it's 1/4 of the circumference. If it was 90 degrees out of 360. So if I went 45 degrees out of 360, it's 1/8 of the circumference. Okay, so let's go ahead and write that. So it's x degrees, it's a fraction of the circumference. So it's x degrees out of the 360. So it's this fraction of, so times of the circumference. So it's 2 times pi times, I'm going to put my radius as 1, because that's what it is on a unit circle. Okay, this right here will convert your degree measure to a radian measure. Can we reduce this a little bit? Yeah, we could reduce the 2 into the 360. How many times does that go? 180 times? Okay, so I'm going to write it like this. So x degrees, in fact, I'm going to reduce that, it's 180. So times pi over 180. Okay, when I reduce it, there we go. Put a little box around that. Okay, this will convert from degrees to radians. So this will convert from degrees to radian measure. Okay, and all that is just a fraction of the circumference because it is the arc length. Okay, and the circle has a radius of 1. Okay, so let's do a couple conversions, and some of these will be familiar. Let's convert some degrees to radians. Okay, so degrees to radians. Let's do this one first. So degrees to radians. So let's say number 1, let's say I want to convert 30 degrees. Now I want to know how many radians that is. Okay, some of these we'll memorize. 30, the 45, the 60s, obviously the 2 pi's and the 180s and everything. But let's go ahead and convert it. So we have 30 degrees times what? How do we convert? Times pi over 180, right there. So times pi over 180 degrees. And we reduce that, and that's how many radians 30 degrees is. So that goes in there 6 times, right? So this is 1/6. 1/6. So we could just write that as pi over 6. Okay, you can write it as 1/6 pi, but we usually just write it as pi over 6. And there it is. 30 degrees is pi over 6. That's how you convert it. Yeah, so I just reduced 30, because 30 goes there, 30 goes in there 6 times. So 1/6. Because that's how we convert. Yep, that's how we convert it. Okay, number 2, let's say we do 90 degrees. So we want to know how many radians that is. Okay, so we'll do the same thing, 90 times pi over 180. Okay, and that reduces to 1/2, doesn't it? Yeah. So pi over 2. 90 goes into 90 once, 180 twice. So pi over 2, and that's something we knew anyway, right? Yes. Okay, so because those are some of the common ones. So let's say we didn't have a common one that we memorized. It's 40 degrees. So 40 degrees. Let's see what that is in radians. So we'll do the same thing. We'll take 40 degrees, and we'll multiply it by pi over 180, 180. And we reduce this fraction, and that's how many radians we have. So how do we reduce this? 2 over 9. So you could actually factor out a 10, just cross those out, right? And then 4/18 or 2/9. So it's 2 pi over 9 radians. Okay, pretty easy. Okay, let me do a couple more degrees to radians, then we'll go the other way. We'll go from radians to degrees. So let's try 210 degrees. 210. Okay, so 210 times pi over 180. So let's reduce out a 0, right? Divide by 10. So we have 21/18. What goes in at 21 and 18? 3. Okay, so 3. Okay, so 3. So that goes in there. 7 pi goes in there 6 times. Yeah, so 7 pi over 6. Okay, now I want to connect the dot here. 210 degrees, when we went through and memorized all those angles, in the first quadrant it was called 30 degrees. Second quadrant it's 150 degrees. Third quadrant it was 210. Fourth quadrant it was 330, right? So 210 was a 30-degree reference angle, right? So if we took sine of 210, it's negative 1/2 and so forth. Well, we have 7 pi over 6. Let me cover up the 7 right there. What was pi over 6? That's 30. That's 30. It helps us get our reference out, especially on the angles that the special angles like the 30, the 60, and the 45. This works kind of nice. So this is a 30 degree. In fact, once you start working with radians, it's going to be actually easier than degrees. Okay. Okay. Actually, let me do one more here. Number 5. Negative 300 degrees. You want to know how many radians that is. Well, the negative, that just means we're going backwards. So I'm just going to, we don't really do anything as far as calculating, but just put a little negative there. We know it's negative something radians. Let's put a negative there. So let's just convert 300. So 300 times pi over 180. So reduce that. 30 over 18. 6 goes in there. Okay, so 5 pi over 3. So 5 pi over 3. So negative 5 pi over 3. Well, let's see if the dot was connected on that one. What was pi over 3? 60. Pi over 4 was 45, but pi over 3 is 60. Right? So wasn't 300 a 60-degree angle? Yeah, we had 60, 120, 240, 300. It was a 60. Okay, so there we go. Okay, so let's go instead of a degree to a radian, let's go the other way. So radian to a degree. So radian to a degree. Okay, I guess I'll call this number 6. So if we, to go from a degree to a radian, we multiply the degree by pi over 180. Well, what do you think we're going to do to go the other way? 180 over pi. So we're going to multiply by 180 over pi. So actually, I'll write that. So you'll multiply by 180 over pi. Okay, and that'll convert it to degrees. All right, so number 6. So let me give you a radian measure. So 5 pi over 6. So 5 pi over 6. So let's take this off to the side here. 5 pi over 6. All right, so let's multiply that by 180 over pi. Kind of convenient. What happens to the pi's? They reduce out, reduce out, reduce out. And then how many times does 6 go into 180? 30 times. And then what's 30 times 5? 30 times 5? 150 degrees. There you go. 150 degrees. That's the conversion. And again, the dot being connected, pi over 6, isn't that 30? And wasn't 150? That was one of the 30s. Yes, that's our reference. Okay. Okay, 7. 2 pi, although we know the degree equivalent to this. So 2 pi times 180 over pi. All right. Reduce that out. 360. Okay, that's what we knew, right? So 360 degrees. Okay, if there's a, because radian measure does not have to have a pi with it. Okay, it's just, if it has a pi, we just kind of leave it in terms of pi. But if it has a pi in it, is the pi always going to reduce out?
Yes, sir.
It is. So mathematically it's incorrect, but a quick trick, instead of just writing it out, because we know it's going to happen if it reduces, quick trick is if we think of pi as 180, okay, pi is 3.14, that'll never change, but if we think of pi as 180, then we can make the conversions in our head pretty quickly. So again, you could do this. Think of pi as 180, so what's 180 divided by 6? 30. 30 times 5? 150. Even this, think of pi as 180. What's 180 times 2? 360. So if there's a pi in your radian measure, you can think of pi as 180. Okay, mathematically, this is 3.14, so it's 6.28 something radians. Okay, but you could think of pi as 180. So let's see, so number 8, if I give you 3 pi over 4. So let's convert that. So you'll be able to use some small calculators, but if you do 180 divided by 4, actually, does anyone know what that is? 45. And then what's 45 times 3? 135 degrees. 135 degrees. Okay? But that'll still, if we do 3 pi over 4 times 180 over pi, that's what happens, right? 4 into 180 is 45. 45 times 3, there you go. So it's 135 degrees. Okay? So let's look at similar. You're going to have to convert, yes. And then the rest of the homework, you're going to be finding some values, just like we did with degrees. Okay, but let's look at common radian measures that will make our life easy if we just memorize it. Okay? So let's draw the 30s, the 45s, and the 60s. Okay, it just makes life easy if you don't have to figure it out. You just kind of memorize these. All right, so let's, like we did with degrees, let's go ahead and draw a 30-degree angle, but it's in radians, so we call that pi over 6. Okay, so this is our 30. So I'm going to write and name all of the 30s. 30 degrees in this quadrant, the 30 degrees reference in this quadrant, and then 30 in this quadrant. Okay, so let's draw it over here. It's closer to the 180. Well, if this is 180, this is 1 pi, right? This is 6 pi. 6 pi. But I got to back it up 1, so instead of 6 pi, this is what? 5 pi. So that's what the radian measure is in the second quadrant of a 30. 5 pi over 6. 5 pi over 6. Okay. So this is 150 degrees. But to get my radian measure, a quick way to look at it, I know that this is 1 pi, 6 pi. So if I want to be in the second quadrant up there, I just back it up 1 pi over 6. So if this is 6, that's 5 pi. 5 pi over 6.
So would 45 be 4 pi over 6?
No, these are the 30s. Okay. I'll get to the 45s and the 60s. Okay, so if this is 5 pi over 6, what's our 30 called in our third quadrant?
7 pi.
Good, 7 pi over 6. Okay, 7 pi over 6. Okay, and if I go in the fourth quadrant over here, well, all the way around is 2 pi. That would be 12 pi over 6 if I went all the way around. But I don't want to go quite all the way around. So I don't want to go to 12 pi over 6. I want to go to what? 11 pi over 6. So if you memorize these as the 30s, then that'll help. Because I'll ask, what is cosine of 7 pi over 6? You'll automatically know where it's at, what the reference angle is, and everything else. We'll know that's a 30 for sure. Okay, these are the 30s. Okay, question? Grant, question?
Oh, I was just gonna ask, are we ever gonna have to do weird angles 47?
As far as memorizing, no. Weird angles like 47, we'll have to convert it. Multiply by pi over 180 and convert it, which does not convert very well, but 46 degrees might reduce a little bit. But yeah, the weird angles we'll have to be able to convert though. Okay. As far as what we're going to work with most, 30, 45, and 60. Then your 90, 180, 270, 360. Okay, 45 degrees.
Are we going to work with
Quadrantals, yes. Like the 90s, 180s. Okay, 45, that was pi over 4. Okay, so first quadrant, 45, that's pi over 4. Second quadrant, let's draw that over 45. Well, if this all the way around 180 is 4/4 pi, what is this one? 3 pi over 4. This is 4 pi over 4. This would be 3 pi over 4. Okay. And then over here, if this is 4 pi over 4, well, over here is what? So go one more. So 5 pi over 4. 5 pi over 4. And then if I go in the fourth quadrant, it's not quite 8 pi over 4, because that would be 2 pi. So this would be what? 7 pi over 4. Those are the 45s. Okay. You could also think of it like this. 1 pi over 4, 2 pi over 4, isn't that pi over 2? 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is our 3 pi over 2, 7 pi over 4, 8 pi over 4. Okay? But these are the 45s. These are the 45s. Okay, and then the 60s. What was 60 in the first quadrant in radians? Pi over 3. Okay. So it's pi over 3 there. So what is it in the second quadrant? 2 pi over 3. Because this is 3 pi over 3. Back it up. It's 2 pi over 3. And then this one is, if this is 3 pi over 3, this is 4 pi over 3. And this is 5 pi over 3. That's a nice pattern there. Okay, 1, 2, 3, 4, 5. So we're good to go. Okay, so those are the 60s. Those are the 60s. Okay. So let's find some values, sine, cosine, tan, just like we did with degrees. So let's find the sine of theta, cosine of theta, and the tangent of theta. So let me start over with number 1. So let's say theta is 7 pi over 4. Okay, so your homework is set up like this. Well, first of all, 7 pi over 4, do we know its reference angle? Okay, what's 45 degrees? Pi over 4. Pi over 4. If you forgot, quick trick, take 180 divided by 4. Pi over 4 is 45. Okay, so let's go ahead and draw it, figure out what quadrant it's in. So what quadrant would 7 pi over 4 be in? Fourth. Okay, so it's 8 pi over 4, so it's over there, it's fourth quadrant. Okay, then when we find the sine, cosine, tan, all students take calculus. This is where they're positive, right? Okay, so it's in the fourth quadrant. So sine of 7 pi over 4, cosine of 7 pi over 4, tangent of 7 pi over 4.
Are all the other classes learning or having memorized all of this as in the unit circle?
And they do unit circle and also memorize as well.
Oh.
The more you memorize, the easier to me it is, whether you use a unit circle or not. So the more we memorize, the easier it is. Okay, so 7 pi over 4, well, it's 45. Which one of these three in the fourth quadrant is positive? Cosine. So I know, remember there's two parts to the answer. It's whether it's positive or negative, and then what its value is. Okay, so do this. All right, so that means sine is negative and tangent's negative, right? All right, so sine of 45, 1 over root 2. Good, 1 over root 2. So sine of this angle 45 in the fourth quadrant is negative 1 over root 2 because sine is negative.
Oh.
Right, sine is negative. Okay. So cosine of 45 is positive 1 over root 2. So 1 over tangent of 45 is, there you go, 1. 1. So tangent of 45 in this would be negative 1. Okay. This is a 315 degree angle. 315. Okay. All right, number 2. 19 pi over 6. We'll do the same thing. It's good review. Even when we did it in degrees. Kind of good review because it's the same process. Okay, so 19 pi over 6. Well, got to figure out what quadrant that is in. So is this more than 360 degrees? Is this more than 2 pi? Okay. If it's more than 2 pi, can't we just take away 2 pi and get a coterminal, same ending place, angle? So let's go ahead and subtract 2 pi. Okay, so let's go ahead and subtract 12 pi over 6. Isn't that 2 pi? Okay, so what does that leave us with? Okay. 7 pi over 6. Okay, so that's a coterminal angle. All right, so let's go ahead and, what quadrant is 7 pi over 6 in? Third. We know that because here's 6 pi, 1 pi. Here's 6, there's one more, so it's over here. So there we go, it's in the third quadrant. All students take. So tangent is negative. So let's go ahead and find, let me do this. Let's call this theta, so we don't have to write that thing. So theta is 19 pi over 6. So we're going to find sine of theta, cosine of theta, and tangent of theta. Okay, we want to find its value. Remember, there's two parts of that answer, whether it's positive or negative. So what I do so I don't forget, I know tangent's positive. So if tangent's all students take, so tangent's positive, cosine's negative, and sine's negative. All right, it's half the answer there, right? Easy half. Okay, so what's our reference angle? 30 degrees. 30 degrees. Pi over 6. Pi over 6. Okay, so sine of 30 is, there you go, 1/2. Cosine of 30 is root 3 over 2. So cosine of this 19 pi over 6 or 7 pi over 6 is negative root 3 over 2. What if we forgot that it's 1/2? Sine of 30 is 1/2. What do? We could look at our unit circle but if we have to fill out that unit circle and we don't have it, what do? We remember the triangle. So you can always do this. 30, 60, 90. If you forget this, then I guess you're in trouble. But if the hypotenuse is 2, the hypotenuse is twice as short legs opposite 30, that's 1, and this is root 3. So sine, sine of 30 is opposite of, well, there it is, 1/2. Cosine of 30 is adjacent over hypotenuse, root 3 over 2. Right? Tangent of 30 is 1 over root 3, and so forth. 60, sine of 60, right? So if you forget, and have your 45-degree triangle as well. Actually, I'll just draw it since I drew that. So 45, it's 1, 1, root, there you go, root 2. Sine is opposite over hypotenuse. So hopefully you don't forget those triangles, but you got it all. What was tangent of 30, by the way? 1 over root 3. There you go. Okay. Couple more here. Okay, number 3. Theta is equal to 2 pi over 3. 2 pi over 3. Okay, hopefully this is getting kind of easy. So the angle is 2 pi over 3. What quadrant is 2 pi over 3 in? Second, because it's 3 pi over 3, so this is 2 pi over 3. Okay, what is our reference angle? 60. Pi over 3. That's 60. 180 divided by 3. Okay, 60. So sine of theta, cosine of this 2 pi over 3. By the way, that's 120 if you want to make a conversion.
This is just sine of theta instead of writing out.
It'll be written for you like that. Okay. As far as I know. Okay, so the values. So Justin, all students take calculus. Which one is positive, the sine, cosine, or tangent in the second quadrant?
Here's the sine.
The sine. There you go. So that means cosine is negative and tangent's negative. Okay, at least we got half of that right. Okay, because there's two parts to it, remember? So whether it's positive or negative, and then its value. Okay, sine of 60 is what? Has a value of root 3 over 2. Cosine of 60, 1/2. Tangent of 60 is the root 3, right? 60 is the bigger number. And there you go. Kind of easy. All right. Okay, let me do 2 more here. Sorry, a little long notes here, but okay, number 4.
2 more?
2 more. Okay, let's say theta is 3 pi. 3 pi. So let's go ahead and plot that. And then we'll find the sine of 3 pi, cosine of 3 pi, and tangent of 3 pi. Well, 3 pi. Is that more than 2 pi? Is this more than 360?
Yeah.
It is. So what do?
Looks like it's going to be subtracted.
We can count, or we can just, let's go ahead and subtract 360. Let's go ahead and subtract 2 pi from that. So if we take 2 pi from that coterminal, same spot, what does that leave us with? 1 pi. Okay, so this is 1 pi. Okay, well, we can plot that. So here's standard position. Where's 1 pi?
Quadrantal.
It's a quadrantal. There you go. So it's 180. In degrees, that's 180. So there it is. So it's a quadrantal. So now let's kind of review sine of our 180. So let's put sine of pi, cosine of pi, theta, and tangent of theta. Okay. So the quadrantals, we thought of the unit circle, the points on the unit circle. And what was a point over here on a circle with a radius of 1? This was at 1, 0, 0. How do we get to this point? Ordered pair, x comma y.
Negative 1, 0.
Good, negative 1, 0. Right, so negative 1 comma 0. Not that we need it, but over here was 0 comma 1 and so forth.
What was the
So,
bottom one? 270.
0, 270. So 0 comma negative 1. And this was 1 comma 0. So then, unit circle. Your x is your cosine. Your y is your sine. This is your cosine. This is your sine. Okay, but we're looking at pi. So what is the sine of 180 or sine of pi? Because your cosine, this is your sine. So 0 has a value of 0. Right? And what's the cosine of 180? Negative 1. And then tangent was sine over cosine, or your y over x. So 0 over negative 1. Is that 0 or undefined? It's 0. It's 0 over negative 1. You can have 0 on the top. So that's 0. It has a value of 0. Okay? Okay. Last one here, because I think some of these are on your homework. Let's call this number 5. Okay. If theta is 11 pi over 6, and they want you to, this is a review problem, they want you to give the ordered pair that's associated associated with this on the unit circle. So they just drew the fourth quadrant because that's where it's at. So this is in the fourth quadrant. By the way, what reference angle is 11 pi over 6? 30. Looking at pi over 630. So it's closer over here, so I'll draw it like that. Okay. And then I'm gonna draw my right angle, my right triangle. And so we know that this is a 30-degree angle. So, but this ordered pair, this location, this is what the question is. They want to know what location this is at. So it's something, comma, something. So we just have to remember what the 30, 60, 90 sides are. Okay, well, if this is our this is our unit circle, so the radius is 1. The radius is 1. So back up here, this was our radius of 2. So if you remember what we did, we wanted this to be a 1, so we just divided everything by 2, right? Everything by 2. And what I think about is this. Well, the shorter leg is going to be the 1/2. The longer leg, opposite of 60, that's your root 3 over 2, right? And if you drew this somewhat accurately, you can see a short leg and the long leg. Okay, so what is this length right there? Root 3 over 2. It's opposite of 60. That's our root 3 over 2. Is it positive or negative? Positive. Okay, what about this one? Negative 1/2. So negative 1/2. So to get to this location, we got to go over root 3 over 2 and then down, so negative 1/2. Okay, and that's the answer they want right there. What the location is, the order.